Good morning, algebra students. This is an extra lesson that goes along with lesson 10.4, and in this lesson we're going to look briefly at how to apply set theory. So as we look at set theory, there's a couple of definitions that I want you to check out. So first of all, a set is a collection of distinct objects. Each object in a set is an element or a member of the set. Now, for example, I have this set listed here. Set A is made up of the members or the elements 0, 10, 20, 30, and 40. The elements or members of a set are going to be listed with commas in between them, and they're surrounded by braces. So that's what we would call these symbols here. So I have a brace on the left, all the elements, and then a brace to close it off on the right. That would be set A. Now, a couple of symbols that we might run into are special sets that are often used. So the first one is the empty set. So there's a set with no elements in it. I would use this symbol right here. It's a 0 or an O with a slash through it, meaning nothing is in it. The empty set or the null set is another way that you might hear that described. The other special set would be the universal set, which means the set with all elements under consideration, and we represent that set with the letter U. Okay? So just to give you a quick example of how I'm going to put this together, most of you are familiar with the teams in the NFL that make up the NFC North, probably the division that most of your favorite teams are a part of, including mine. If I was to list that, I could use set notation to write out the set that includes the NFC North. So if I said, here's the NFC North, well, which members make up that set? Well, that'd be the Green Bay Packers, that'd be the Minnesota Vikings, it would be the Chicago Bears, and it would be the Detroit Lions. And then I'd close off that with my set notation again. So those four items would be the elements making up the set that is the NFC North. Now, continuing on, a couple other symbols we'll run into. We can perform operations on sets using a couple of the symbols you see here. So the first one is, if we're asked to find the union of two sets, that'd be written this way, A-U-V. And again, this U isn't italicized like the letter U would be, it's just a symbol. So this symbol, again, it looks like a U, stands for union. Show me what that might look like. That would be if I were to take, what's going on here? There we go. The union of set A and set B. So that would mean any item that's contained in A or B or in the overlap that's in both of them. That's the union of the two sets. The intersection of two sets A and B is written a little differently. So notice that U symbol that meant union gets flipped over. Now it means intersection. So this is the intersection of set A and B. So that's going to represent all the elements that are in both A and B at the same time. It's the overlapping part that we talked about in the other lesson. So again, representing the U right here, that means the universal set. That's all the elements that are in consideration for that particular group. The last symbol with which we need to be familiar is a bar written over the top of it. So just like A bar within the lesson meant complement, A bar here means the complement to a set. So if I have the complement of set A, that would be any item that is not in A. So if set A would be here, the complement to that would be everything else, everything but something that's in set A. So now that we're familiar with those three symbols and the operations that we will perform, let's go ahead and work with those a little bit. So here we're given the universal set, meaning here's all the numbers we're going to consider. 0, 5, 10, 15, 20, 25, 30, 35, 40. Set A includes the power or the multiples of 10, and set B we've got multiples of 5 up through 25. And we're asked to then find the indicated set. So our first operation tells us find the union of A and B. So we're going to write union. Now that would mean any item that is in either A or B or in the overlap. So what I'm going to do is I'm going to look at set A. I see 0, okay. To put these in order, I see 0, 10. Well, I notice a 5 over here. So I'll put the 5. I got a 10 that's in both. I got 15 that's in B. I got 20 that's in both. I have 25 in B. And then I've got a 30 and I've got a 40 that are part of set A. So that would be the union of sets A and B. It's in either A or B or both. Our second example, the U that's upside down, this symbol, remember that means the intersection. So that means any item that's in both A and B at the same time. Well, this is a little bit smaller list. So if we pick out all the numbers that are in both, 0 is not, 10 is in both, that's good. 15, no, 20 I see in both of them, that's good. And that looks like it's it. Those are the only two overlapping elements. So 10 and 20 will be the elements of this set that is the intersection of sets A and B. Next up, we're asked to find the complement of A. So that's going to be anything that's not in set A but is part of the universal set. So what I'm going to do is I'm going to look at my universal set and I'm going to cross out anything that's in A. So let's see, 0, 10, 20, 0, 10, 20, 30, and 40. Those are the elements that are in set A. So the complement to A would be everything else. Well, everything else includes 5, 15, 25, and 35. Our last example, we're asked to find the two things. We've got the complement to the intersection. So the complement to the intersection of A and B. Now as we write this one out, the intersection of A and B we've already found right here. That was 10 and 20. So the complement to that is going to be everything but 10 and 20. So I go back to my original list. It's everything except 10 and 20. So as I write those out, we've got 0, 5, 15. And then we've got 25, 30, 35, and 40. So that would be the complement to the intersection of A and B. Our final example, we're asked to look for another feature of set. So this is now working with the idea of a subset. As defined here, we're saying that if every element of a set A is also an element of set B, then A is a subset of B. And this relationship is written as you see here. A is a subset of B. So we've got kind of that U shape is now on its side with a line underneath it. That means subset. So here in the diagram, you'll notice that A is any number that's in here. Well, any number that's in A is also in set B. So that would make A subset of B. U being the universal set that we're working with. Now, don't let the diagram affect your idea as you look at these particular numbers, because now I'm going kind of the other way. Set A is a little bit bigger than set B. So again, that diagram does not match up with the numbers that you see here, and that's okay. So we're asked, is B a subset of A? Meaning, is every item or element in B also found in set A? Let's see, I've got negative square root of 2, and I've got 7, and I've got 8. All three of them are part of set A, so I can say yes, B is a subset of A. Oh, if I were to go the other way, is A subset of B? Well, it can't be, right? B only has 3 elements, and A's got 6 elements. All of these don't show up here, so we're going to say no to that question. Our next one's a little bit trickier. Is A subset of, you remember what this symbol means? This symbol means the intersection of B and C. So is A subset of the intersection of B and C? So the intersection of B and C would be any number that overlaps in both of them. Well, I've got nothing. So there is nothing that overlaps in B and C. Well then, set A must not be a subset, right? Because it's not a subset of nothing, the empty set. A question I have for you would be this. What if we were to turn this around and ask, is A subset of the union of B and C? Well, the union of B and C would be putting everything together. I'd have negative square root 2, 7, 8, negative 6, 0, and 3. Would that include all of the elements from set A? Let's see, negative square root 2, 7, 8, negative 6, 0, 3. Oh, yes, it would. So just that little difference in notation makes a big difference in our answer. So that should give you enough to be able to work through the problems on applying set theory in the extension to lesson 10.4.